The first shape we're going to look at to calculate the area is going to be the rhombus. Now the formula for the area of all kites, so the area of a kite, so I put a small k down here, is 1/2 the length of the two diagonals multiplied together. So diagonal 1 and diagonal 2. So take their product, take half of that, and that'll give you the area of any kite. Now if you remember from our quadrilateral hierarchy, we started off with quadrilateral at the top. We had trapezoid, parallelogram, and kite. Under kite was rhombus. So this formula for the area of a kite applies to rhombuses. So we're going to use it here. Now when I look at the problem as given, there's a problem. I don't have both diagonals. I have this diagonal, which is 10 units. I do not have that diagonal. Now there are some things that I do know. For example, I know that since it's a rhombus, all 4 sides must be equal. Therefore, this side is 12. Rhombus is a figure that quadrilateral that has 4 equal sides. I also am now looking at a right triangle right here. That's a property of being a kite, is that the diagonals intersect at a right angle. It's also a property that it bisects one of the 2 angles. At a parallelogram, they bisect each other. So I know that in this figure, this length and this length must each be 5 units. So again, it's a rhombus, which means it's a parallelogram, which means the diagonals cut each other in half. It's a kite, which means they intersect at right angles. So to make this problem work, I need to pull that triangle out. So I can get this length. Now, many problems will simply provide for me diagonal 1, diagonal 2, and I can plug them into the formula. Not a very interesting problem in its own right, which is why we're practicing this one. Now, I can use the Pythagorean theorem to solve that. I've got C, A, and B, so I can write 5 squared plus x squared equals 12 squared. Math happens. Multiply that out. And handy dandy calculator to carry the rest of the way. 144 minus 25, take them square root. And I'm left with x is on the order of 11. I'm rounding a bit there. It's actually 10.908. But again, to keep the math easy, let's just call that 11. So that makes this distance 11. I want to redraw my rhombus now with my known information. It's going to be a little smaller, make it all fit. Let's kind of maybe make it look a little more like everybody's the same length. So there's my rhombus. I know this diagonal is 10. I know this diagonal is 11 plus 11, or 22. So remember, this distance here, this piece right here, that is this piece right here. That's only half the diagonal. Now I can go ahead and put everybody in my formula. Area is going to be equal to 1/2 diagonal 1 times diagonal 2, and then evaluate. Half of 10 times 22 is going to put me at 110 square units. Now, I don't know what the units are in this particular problem. They're not given. So I would put those units, whatever they are, and then I make sure I square them.